last thing we're going to talk about with probability is the difference between theoretical and experimental probability. So theoretical is like what should happen. For example, should happen. I'm flipping a coin 2 times. I think I have I'm flipping a coin. I think I have a 1 out of 2 chance of getting heads. But it depends on, versus something if you actually did an experiment, how many times do you get heads and how many times do you get tails? So that's the difference between theoretical is just in theory. If you have a dice that has 6 sides, you think 1 out of 6 times you're going to get a 1. If you have a coin, you think 1 out of 2 times you're going to get heads. Experimental is if you actually did an experiment, what did happen? So here's an example. Jim tossed a coin 35 times. He recorded whether the coin showed heads or tails. Use the results of the table to find the experimental probability. So looking at this, good old tally marks, he got heads 5, 10, 15, 20 times. He got tails 5, 10, 15. Okay. So what is your probability of heads? That is 20 out of 35, which does reduce to be 4 out of 7. Or I'm going to go ahead and put that as a decimal, and I'll show you why here in a second, just because I think it is a little, I'll just leave it here. Oh yeah, no, it says to the whole percent. Let's say 0.57, okay? That's rounded to 2 decimal places. Probability of tails is 15 out of 35, or 3 out of 7, and that is going to be 0.43. Makes sense, right? Because, it's either heads or tails. So these 2 numbers should add up to be 1, okay? Or if you change them to percent, that would be 57%. 43% adds up to be 100%. So that's another basic thing about probability. What is the theoretical probability of throwing heads? Well, that is 1 out of 2, or 0.5. Right? Same thing with tails, 1 out of 2 or 0.5. That's in theory. If I throw a coin, 1 out of 2 is going to be heads. And then this question, what is the difference in the experimental probability of throwing heads and the theoretical probability of throwing heads? So if we use our experimental, and usually a couple things we do. When we're doing this, it says difference. We want to know literal the difference. Lots of times we don't worry about the positive or negatives, but I am, okay? Experimental minus theoretical. That's what they want you to do. So our experimental was, and I'm going to go ahead and use the decimal, 0.57 minus 0.5, that's a minus sign, equals 0.07, or 7% difference. Okay. The difference in throwing tails, I'm going to keep going the other way. So this one was 0.43 minus 0.5 equals 0.43. Come on, kids. Is that a negative? Is that also is that a negative 0.7? It should be. Yeah, that's a 7. Negative 7%. That looks really nice. Very professionally done. So that's the difference in our experimental and theoretical probability. So looking here at the back, we have another one. We have a couple more, I guess. So we spun a spinner 30 times. Okay. The following is a record of the results. So again, I'm just going to add these up. That's 1, 2, 3. Each one of these is 5. So that's 6 times you got yellow. That's 8 times you got purple. That's 4, right? 4 times. That's 5. And that's 7. You should double check. I always double check when I count these things up that it actually adds up to what it's supposed to be. So that is 10, 30, right? Adds up to be 30. So good. I probably marked all those numbers down right. So find the experimental probability. Probability of a yellow. That was 6 out of 30, okay, which reduces to be 1 out of 5. Again, you could do the decimal. I guess I will. That's 0.2. Yeah, I'm going to put both of them on there. Purple is 8 out of 30, which is 4 out of 15. which is going to be, ooh, gross, 0.2, let's say 7. It's really 2.6 repeated, but I'm going to say 2.7. Probability of blue is 4 out of 30. Again, both of those reduced by 2, so 2 out of 15. 2 divided by 15 is going to be 0.13. Again, that's 3 repeated. Probability of green is 5 out of 30, or 1/6. 1/6 is like 0.1, we'll say 7. Red is going to be 7 out of 30. That doesn't reduce. 7 out of 30 is going to be 0.23. And really quick, just stopping right there, since those are all my possibilities, right? Yellow, purple, blue, green, red. All of these decimals I added up here, and really all the fractions too, should add up to 1. So I'm going to check that real fast. 0.2 plus 0.27 plus 0.13 plus 0.17 plus 0.23 does add up to be 1. Okay, so that's a good sign that I've calculated my probability correctly. Okay. This or question, green or blue, we basically just add up the number of green to the number of blue. Okay, so probability of green is 5 and 4, so that's 9 out of 30 times. Again, those reduced by 3, so it's 3 over 10, or 30%, 0.3. Sorry, I shouldn't have put the 0. Yellow or purple, again, yellow and purple, 6 plus 8 is 14. That's 14 out of 30, which reduces to be 7 out of 15. 7 out of 15 is going to be 0.4, we'll say 7. And then probability of red or blue would be 11 out of 30. So 11 over 30, which I should have just wrote on the line because that definitely doesn't reduce, is 0.37. Okay. Now just a little side note here. Well, never mind. I'll just leave that alone. We're good to go. Cool. What is the theoretical, though? And so with this theoretical, we're going to assume that all of these color parts are the same size. You know, so I have a little spinner, and it's perfectly designed into 5 equal size pieces. Okay. So theoretically, if those are equal size pieces, then this is going to happen 1 out of 5 times, and this is going to happen 1 out of 5 times, and this is going to happen 1 out of 5, 1 out of 5. When you have more than 1, and these are all 0.2s, right? 0.2, 0.2, 0.2, 0.2. When you have more than 1, then that's going to be 2 out of 5 times. 2 out of 5, again, 2 out of 5, and 2 out of 5, or 0.4, right? Okay. What is your difference between the experimental and the theoretical of spinning a yellow? Well, the theoretical of spinning a yellow was a 0.2 minus the experimental was a 0.2. That is going to be 0% difference. I guess I could turn that into a percent. Would that make you feel better? Probability of spinning a red. So again, theoretical up there was a 0.23 minus 0.2 equals 0.03, or 3% difference. Okay. We're talking about spinning a red or a blue. So up here, red or blue was a 0.37. Slide this up a little. 0.37 minus, theoretically, it would be a 0.4. So 0.4 minus 0.37, or 0.37 minus, is going to be a negative 0.03, or negative 3%.